Welcome back. Let's talk about elements and compounds. This will also be a two-part lecture because I don't want it to go too long. So, distinguishing between elements and compounds. How are elements and compounds different? An element is the simplest form of matter that has a unique set of properties. Oxygen and hydrogen are two elements. There's more than 100 known. Elements after 92 are man-made elements or synthetic elements, and they don't stick around very long. They're very short lives, so it's kind of interesting. A compound is a combination of two or more elements, and they are always in the same proportions. Like water always has two hydrogens and one oxygen. If it doesn't have two hydrogens to one oxygen, it's another compound. Carbon, oxygen, hydrogen can combine into the compound sugar or sucrose, and every sample of sucrose there are twice as many hydrogen particles as oxygen, and the proportion of hydrogen particles in sucrose is fixed. It cannot change, or it wouldn't be sucrose. There is a difference between elements and compounds. I can break compounds down into elements, but elements cannot be broken down further by standard chemical means. We can break them down in like an atomic bomb, which is what happened at Hiroshima, but typically we can't break them further down than the element. Physical methods are used to separate mixtures, but they cannot be used to break down compounds. So I can separate sand from water by filtration. I can separate sugar and water by distillation. I can distill or boil off the water, leaving behind the sugar or sucrose. If I want to break down water, I actually have to use some other method, usually electrolysis for water. So it doesn't mean that sucrose cannot be broken down and water can't be broken down. It just means they can't be done by simple physical methods. We have to use some kind of a chemical change. So a chemical change is a change that produces matter that is different in composition than the original matter. So these would be your chemical changes like rusting of iron to produce, or rusty nails, that kind of thing. When we heat some samples like sucrose, or is this sucrose? Yes, this is sucrose. If I put sugar in a pan and I start heating it, the middle picture shows it turning into caramel, which is where I would stop. But if we continue going on, we can actually make it into solid carbon with water vapor. And that is not good. It doesn't taste good. It is not delicious. So, can substances that are produced when sugar is broken down when heated be broken down further? And the answer to that would be no. We can't use a chemical process for that, or a chemical change. We would again have to use something like a nuclear process, an atomic bomb. So here is a representation of a chemical change. If we take sugar and we heat it until we get carbon and water, the water would be a vapor. We'd have to collect that water vapor. And then if we took the water vapor and sent an electrical current through it, we could break it down further into hydrogen and oxygen. In general, the properties of compounds are quite different from those of their elements. So sugar tastes great. It's a white solid, but carbon is black and tasteless. Can elements be broken down by a chemical change? Can compounds? And you should know the answer to this right now. And the answer is for elements, no, it can't be broken down by a chemical change, but compounds can. Distinguishing between substances and mixtures. How can substances and mixtures be distinguished, or how can we tell them apart? And we are going to have a flow chart, and you're probably going to want to write that down at some point. Deciding whether a sample of matter is a substance or a mixture is based solely on the appearance and can sometimes be difficult. Something like homogeneous milk is a homogeneous, it says it's homogenized, but it's actually a mixture, and it can appear to be only one kind of matter. But we know that water has milk has a number of different components. Sometimes you can decide based on whether there's more than one version of the material in question. So let's go back to my example of milk. We have whole milk, low fat, light cream, heavy cream, no fat. So there's many different versions. And so that's telling you there's a different amount of milk fat in the milk, and therefore it must be a mixture. If the composition of a material is fixed, like in water, then the substance then the material is a substance. If it can vary, then it must be a mixture. So water is a substance, but milk is a mixture. So here's the flow chart I'm going to ask you to understand and be able to apply. And you're going to want to write this into your notes, and I am going to be checking for it. And so once we have matter, we are going to decide whether it's a substance or a mixture of substances. And a mixture of substances could be physically separated. If you follow down on the substance side over here on the left, a substance has a definite composition, and it could either be an element, and that would be something like carbon or gold, or it could be a compound, and the compound would be something like water. And if it is water, I could break that compound down with chemical methods to make it into the elements. If it is a mixture of substances, it can either be homogeneous, meaning it has a uniform or constant composition. This would be called a solution as well. Or it would be heterogeneous mixture, which would be non-uniform throughout. It's something that has distinct phases or distinct coloration variance in color. Something like granite is a good heterogeneous mixture. So, no matter what you do to a silvery liquid, it doesn't seem to change. Is it more likely to be a substance or a mixture? Well, would be a substance because it would not separate, and therefore it isn't manipulated. If you manipulate it by chemical or physical means and nothing happens, it should be an element. Okay, we are going to stop here. I will have a second part 2 for this video so that you can not have too long of a video to watch. Thanks for watching. See you later.